we discussed about an increasing function, right? An increasing function, decreasing function, what do you call, strictly increasing and strictly decreasing. So if you remember, let's say let's say we have an interval, and today we'll do problems. We have an interval. The interval is I. Children, interval won't be like I, interval would be like minus r, plus r, minus infinity, plus infinity, 0, pi by 2. So the interval I means I is something like this. From here to here is I. Got it? And in this interval, we pick up any two numbers, or sorry, any two values, say x1 and x2, any two values, x1 and x2, such that we find x1 is less than x2. Got it? And our whole discussion is about a function fx. We want to find out what is the nature of this function. Does it increase? Does it decrease? Does it somersault? Whatever it is. So we take 2 points x1 and x2, and then we find the values of fx1 and fx2. And we are able to find a relation that if x1 is less than x2, then the function values also follow the similar trend of relation. This thing is actually explained by this graph. Then such a function is said to be increasing. Okay. So how do you see the increasing trend? We see the increasing trend like this. So I said that this was my interval I. In this, I picked up a value x1 and an x2. Okay. I picked up x1 and x2 such that I said x1 is less than x2. But when I try to plot their fx values, I get the same relation. See, this is fx1 and this is fx2. So if you increase the input, the output also increases. Such a function is called an increasing function. Got it? If by increasing the input, the output decreases, the function will be known as a decreasing function. And if we see that the function is increasing like this and has become stagnant, then what do we say? This is strictly increasing, this is just increasing. When will I call it not an increasing? When the slope falls down. It just falls down, I'll call it not increasing. So go by literature. You are increasing, but now your performance has become stagnant. I can't say your performance has deteriorated. Neither can I say you are improving. But mark my words, I can't say your performance is deteriorating. Got it? So your performance is deteriorating and suddenly you're showing this trend. Can I say your performance has improved? No. I will say your performance is deteriorating, but now is stagnant. Such things we will call increasing, decreasing. But if the trend is like this, we will call it strictly increasing, strictly decreasing the other way. Are we fine? Another way to look at increasing and decreasing, as I told you, if the graph is given, life becomes very easy, but you won't know how to plot the graph of every equation. So now we will take a trend where we will try to plot what is known as the derivative of the graph. The derivative is always the tangent. Remember, derivative of a graph is the tangent. So now our idea will be like this, that given a function fx, we will try to find out what is the value of f dash x. Have you understood? If the derivative increases, function is also increasing. If derivative decreases, function also decreases. How about if the derivative is 0? Function is neither increasing nor decreasing. So now what we will do, we will be given an interval. So our job will be, in the question, a function will be given. They'll ask you, check it in this interval. Okay, very good. I'll check it in this interval. No issues about that. And once the interval is given, you know what are the endpoints. The endpoints will be some a and b, like minus infinity, infinity. I will first calculate what is known as the derivative. And I will equate the derivative to 0. Means what? This is a point where function is neither increasing nor decreasing. Got it? Say for example, a function like this. I'm getting a point somewhere here. At this point, I'll say the function is neither increasing nor decreasing. Before it, I see a decreasing trend. After it, I see further decreasing trend. Whatever, we can compare about it, right? So once we equate this equal to 0, we will get a value of x and we will call this as the critical point. This is very necessary. Critical points can be 1, can be 2. If your f dash x is a linear equation, you get one value of x. Suppose this function was cubic, derivative will be quadratic. Quadratic on solving will give you 2 critical points. Say we have got 2 critical points. So this is one critical point, this is one critical point. Now you have to test here, test here, test here. For what? F dash x. Any arbitrary point. If you find f dash x is greater than 0, here the function is increasing. Less than 0, decreasing. Greater than 0. So shall we take some problems and do? It will become easier for us. Okay. So let's take some problems and try and see. This chapter from now on, all the problems are very interesting. So we'll solve some. Okay, don't preferably don't look at the book initially because you will have a prejudice. So I'll do it in a very detailed manner. Okay. So the question is, you can start seeing the problem from here. I have a function fx, and this function is given as x cube minus 3x square plus 4x, and they say x belongs to R. Let us first read the question. What type of function do you say, children? Algebraic function. An algebraic function which is taking inputs as real numbers. Ananya, clear beta? Are we able to understand, right? An algebraic function which is taking inputs as real numbers. So what will I call it? A real valued function. Understood? Real valued function means where can you give your input? A real axis is the x-axis. And my inputs can range from negative infinity to positive infinity. Do you agree or not? Right? So if I before even reading the question, if I would like to plot its domain, my domain would be this. This is my domain, and I would say my domain ranges from negative infinity to positive infinity. Sir, why did you do this? Because x can take all real numbers. Is this understood? Right? Okay. This can also be written as x belongs to the interval negative infinity, positive infinity. In infinity, we can never have closed intervals. You know this? You can't. This bracket means you cannot touch. Understand that difference? Square bracket means you can touch that value, right? So what is our first step? Okay, and it says show that the function given by this, they are saying, is increasing on R. Means it says take any value from R, the function should be on an increasing trend. Chalo test करके देखते हैं. Solution, we write f of x is equal to x cube minus 3x square plus 4x. This is my equation, x cube minus 3x to 4x. My first job will be to find out what is the derivative of this function. 3x square minus 6x plus 4. Yes or no? Then I write at critical point, my f dash x should fetch 0. चलो इसको equate करते हैं. So I get 3x square minus 6x plus 4 is equal to 0. Children, is anything common possible? No. 3 and 6 was there. So I do middle term splitting. 3 4s are 12. And 12 can be 12. Get two factors. 12. Get two factors, which gives me a 6. 3 and 4 is equal. Is it correct? 3x square minus 6x plus 4. 4 and 3 is 12. 12 we can get by 3 4s are 12 and 2 6 are 12. Nothing is fetching you a 6. Yes or no? No. The question is correct. Yeah. So how do we solve this question? This is a little bit tricky, so let's do it like this. 3x square minus 6x plus 3 plus 1 is equal to 0. Can I write this? And here I am making it 3 into x square minus 2x plus 1 is equal to 0. Can I do this? Okay. Now I'm writing 3 into x minus 1 whole square plus 1 is equal to 0. Is it? Yeah. This is a very weird problem, huh? Just a very weird problem. This value will always be greater than 0. Why? You have to develop that. This is a x minus 1 whole square. Whatever value of x you put, let's take any two random values. If you put 2, it is greater than 0 because it's a square. If you put minus 2 also, this will give you positive, right? And if you put 0, then also it's giving you positive. So this value is always greater than 0. Are you getting it? We write, thus f dash x is always greater than 0 for every x belonging to R. Did you get the logic or not? Tell me. Whenever you get a x minus 1 for any value, it is greater than 0. Therefore we can write fx is increasing on R. You don't have any critical values for this. You don't have any critical values. Everywhere in this interval, the function is increasing. Did you understand or not? If there is any logic issue, tell me. In further problems, we will get critical values. Okay? Clear? Ananya, clear? This one? Let's take one more. Our next question is, our function is f of x equal to cos x. Function is f of x equal to cos x. The first thing we have to prove it is decreasing on in 0 pi. Means we will see this function and its trend in 0 pi. Okay? Chalo. Solution. You have to show that this is decreasing. What is f dash x? Negative of sine x. Negative of sine x. Now let's look at the sine x curve between 0 and pi. In fact, we could have done it by our derivative test also, but let's first do it this way and show you what the book has done. So this is 0, this is pi by 2, and then this is pi. Got it? Okay. So sine 0, 0. This is 0 to pi, right? This is 0. Okay. This is the function of what? This is the function of sine x, not minus sine x. This is pi by 2. This is pi. So if you see, sine x is positive in the interval 0 to pi, right? Sine x is positive, so minus sine x will be negative. Therefore minus sine x is negative from 0 to pi. Have you understood this or not? So they have asked us, show that it is decreasing. Acha, you don't believe, let us see this. Let us see this. This is what beta, negative pi by 2. Try to plot cos x. How is a cos x function? This is cos x function. Agreed? 0 to pi by 2, what is the trend of cos x? Decreasing. How did you find out? Through the derivative test. Right. In fact, to find out the points also we could have found out. Say, if we do it in our way, then we will put negative sine x is equal to 0. So sine of x is equal to 0. Sine of x is equal to 0. Sine of x is equal to 0 means x is equal to what? N pi. At all pi, sine becomes 0. Got it? So 0 and this is pi. N pi means 2 pi. These are my critical points. At this point, this particular function, what is the derivative? The derivative is negative of sine x. Between these 2 points, at this point the derivative is 0, at this point the derivative is 0. Let us check any point between here. Take any point. Pi by 2. What is sine pi by 2? Sine 90? 1. Sine of minus 90? Minus 1. That means which is less than 0. So the function is decreasing. No, these problems, nobody will ask you such type of problems. If they try to ask you, then you can just straight away write it. Here we don't need to do critical analysis. We will write f dash x is equal to minus sine x. And you can write down minus sine x is negative between 0 pi. So you can show that sine x is positive. Like before I drew the yellow one. Yellow one was to prove you that the cos function is actually decreasing. So you just draw the sine x. Sine x function is positive. See, it is above 0. So negative sine x will be below 0. You have to see what is the f dash x. If the f dash x, I hope you remember, f dash x greater than 0, function increasing. F dash x less than 0. So they asked us, show that the function is decreasing. So in this interval, we should show that f dash x is negative, which we have shown. Okay, the same question continues further, and the same question is asking me, it says that show that the function is increasing in pi to pi. Pi to 2 pi, I have to show that the function fx equal to cos x is increasing. Achha, you tell me, children. In order to show that this function is increasing, what you have to prove? You have to find out the f dash x, and you have to show that the f dash x in this interval is positive, right? So let us make our say the sine. Ultimately we will get a sine x graph only. So let us just make it here. They have asked you to check between pi and 2 pi. So the sine curve will be pi by 2, pi, 3 pi by 2, and then 2 pi. Correct? So let's solve this. So I will say f dash x is equal to negative sine x. Now I have to show that negative sine x is increasing. Now let's plot sine x. I don't know how negative sine x graphs looks like, but I'll plot a sine x curve. A sine x curve will increase like this and go like this, where this is 0, pi by 2, pi, 3 pi by 2, and this is what beta? 2 pi. Mind you, children, they are asking me to analyze this graph between pi to 2 pi. And what is this graph? Sine x. So what do you write? You write sine x is positive, sine x is negative in pi to pi. Did you understand this statement? Sine x is negative because sine x is coming below the x-axis. That means that is negative sine x is positive in pi to pi. Hence, fx equal to cos x is increasing in pi to pi. Okay? In pi to pi. So your function was, you found your function, not this, your function is what? fx equal to cos x. You found it increasing in this whole interval. You found it decreasing in this interval. You know what is this tricky question now? Now the tricky question would be, tell me what is the function's behavior from 0 to 2 pi. What is the behavior? Neither increasing nor decreasing. You scored full marks in first term and scored 0 in the next term. So what is your overall performance? 0. Neither increasing nor decreasing. See the same function. Please children, this is a sin x function. We are commenting on cos x based on the derivative of cos x, which is negative sin x. Sin x increases, so minus sin x is, sin x is positive, so minus sin x should be negative. Minus sin x negative means cos x is increasing, no, decreasing. fx equal to cos x, f dash x equal to minus sin x. Now this value can be of two types, positive, negative, right? First time you tested in which interval, beta? 0 and pi. Between 0 and pi, sin x is positive, therefore sine of minus sin x is negative. So this is 0, this is negative. That means cos x here is decreasing. Got it? Then from here to here you found sin x decreasing, which means negative sin x is positive. This is the value from pi to 2 pi. So here what did you found? You found it positive. Therefore here cos x is increasing. Now you are trying to find between pi to 2 pi, increasing, decreasing, both nullify. You say function is neither increasing nor decreasing. Have you understood? Such questions also may come. Usually you should understand these are all argument mathematics. Clear? Now we actually get into our problem zones. Now no more graph. We will be typically seeing with f dash x analysis. This was graph analysis problem where you know graphs. Now we will get questions where we don't know about graphs at all. You might then ask, sir, have a look at the first problem once again. Let's look at the first problem. Sir, in this problem also you did not draw a graph, but you commented. I didn't draw a graph, but I finally got an expression which is commentable. Every time I won't get like this. So now we are going to enter that zone where you neither know the graph trend nor you will get such sort of a one-of-a-kind solution, right? So here now we have to go by zone analysis. So let's start. And this is the interesting part of the chapter. Let's do. So it says, I have a function f of x given by x squared minus 4x plus 6. They're asking me that find the intervals. You get me the intervals where the function is increasing. That's your first part of the problem. And you also get me the intervals where the function is decreasing. Have you understood? And this is an algebraic function, children. So it's a real valued function. So what should be the domain of this function? R. This function is valid from negative infinity to infinity. Now in this whole input range, this is an input. This function will be somewhere increasing, somewhere decreasing. They're asking me to, and you look at this function. Is it not a parabolic function? Yes. The function will be plotted from 6. 6 is your y-intercept. And the function should open up something like this. So somewhere the function will be decreasing, somewhere the function will be increasing. We're supposed to find that, okay? So let's start our solution. fx equal to x square minus 4x plus 6 is a real valued function. the first line I'm writing, that is X belongs to the R family. X can take an input anywhere in R. Okay. Now I write at critical points I'm writing points, f dash x should be equal to 0. So let's see. So 2x minus 4 should be equal to 0, or 2 into x minus 2 is equal to 0, or x minus 2 is equal to 0, or x is equal to 2. Now what is x equal to 2, beta? X equal to 2 is a critical point. At this point, neither it is day nor it is night, right? So this is your critical point, x equal to 2. Now entire magic will happen either on this side or on this side, right? Okay, now we say checking f dash x in, how do I write this? Negative infinity and 2. Okay, negative infinity and 2. Acha, why did I not take 2 as a square bracket? Array, because at 2 the function is f dash x is 0. At 2, have you understood? At 2, function is neither increasing nor decreasing. So I will just go up to 2. So what number should I pick up, children? 0. Let's check f dash of 0. F dash of 0 will give me how much? What is f dash? Now, please understand. When you are taking f dash x, don't take this value, huh? Take this value. This. So we take 2 into 0 minus 4. How much is it? 0 minus 4, which is negative. Got it? Therefore, fx equal to x square minus 4x plus 6 is decreasing in negative infinity to 2. Now you check on this side, checking f dash x in 2 positive infinity. So what number should we take? Let's take f of 3. F of 3 means 2 into 3 minus 4, which is 6 minus 4, which is positive. Therefore, fx equal to x square minus 4x plus 6 is increasing in to positive infinity. If you have a we can ask this Ananya also, or if you have a mobile, you can just go to Google and say graph, just type this graph and you see how is the graph trend. Just type graph, 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 y equal to, or fx equal to, just type graph y equal to, oh, slept. Let's see on this one. She's on computer, she can do it, it will be faster for her. Okay, so let's say, okay, tell me the equation, graph y equal to x square, then look at the graph, see. Now just see, do you see at 2, up to 2, that point will be 2. So up to 2 the function was decreasing, and beyond 2 the function is increasing. I found the critical point. That nature which Ananya has drawn, graphed it, right? That nature is actually, since it's a parabolic function, the graph will be showing something like this trend. This is what is the graph. At 2, it is neither increasing nor decreasing. Slope is 0. So slope is reducing, then slope started increasing. Interesting? These are interesting problems. Chale, ek aur kare? Okay. Chalo. Okay, we have a function fx equal to 4x cube It rained for a few days and then after that, I don't know, it has become once again sultry to the power infinity. Today it was so sultry, so sultry. Fx square minus 4x cube minus 6 square minus 72x. And getting outside our society, I feel like we are walking in craters of moon. Plus 30. Okay, what do you need to do, children? You need to find the intervals where it is increasing, decreasing. Now it will be interesting. Now see, the f dash, this is a cubic function. So the derivative will be quadratic. Quadratic means I will get two critical points. So your labor increases, zone 1, zone 2, zone 3. We have to check in 3 zones. Right? So I can already predict that the domain of this function is a real valued function. So bacha, my domain would be negative infinity to positive infinity. And I write fx equal to 4x cube minus 6x square minus 72x plus 30 is a real valued function. X belongs to R. Okay, bacha. So route f dash x at critical points. At critical points, f dash x must be equal to 0. So let's see our critical points. 12x square minus 12x minus 72 should be equal to 0. Check 12. 4 3s are 12, 6 2s are 12, and 72. So we can 12 5s are 60, 12 6s are 72. X square minus x minus 5 is equal to 6. 6 is equal to 0. Is the question coupled correctly, or plus 30 minus, yeah. So solve this. 6. 3 and 2 will give us 6. Yeah. So let's solve it. X square minus plus 2x minus 3x minus 6 is equal to 0. Or x into x plus 2. Here I must get x plus 2. So here I will get a minus 3. So dog, take dog common. So you have x minus 3 equal to 0. Solving this, we will get x equal to minus 2, x equal to 3. Okay, bacha? So your critical points are available now. One of the critical point is x equal to minus 2. Another critical, so we just write, say, minus 2. This is minus 2, and another critical point is 3. So now you have to check in 3 zones. 3 different zones we will check. Okay. Checking fx in negative infinity minus 2. What value can you take? Minus 3? Okay, let's check. F dash minus 3. Just see the value. Okay, bacha, when you are taking f dash minus 3, so you can take it from this value also, not an issue. So this will be minus 3 plus 2 multiplied by minus 3 minus 3. So what it should be? Minus 3 plus 2 means you get a minus 1 multiplied by minus 6. So this is positive. Positive, or you can write as you want. You can write this is greater than 0. F dash minus 3 is greater than 0. Therefore, fx is increasing. Very good. So in this zone you found increasing. Check for zone 2. Checking in fx in negative 2, 3. So what number should we pick up? 0. 0 is a better number out here. F dash 0. So my f dash 0 should be what? 0 plus 2 into 0 minus 3. So 0 plus 2 is a 2 into a minus 3. So we write f dash 0 is less than 0. Therefore fx is decreasing. So this is a decreasing zone. Champion baniye aap log. But now you will check in fx in 3 to positive infinity. ठीक है ना? So what do we write here? What number would you take? 4. F dash 4. F dash 4 would be 4 plus 2, 4 minus 3. 4 plus 2 and 4 minus 3 means f dash of 4 is greater than 0. Therefore, fx is increasing. Okay. Increasing in 3 positive infinity. Now just ask yourself a question. We don't know what is our function. This is our function. Okay, we'll again ask Ananya to graph this function. Okay, just see the function is increasing here. Up till here the function shows an increasing trend, then the function shows a decreasing trend, and after that the function is again increasing. Ananya, can you help us graph this function on your mobile? Slowly, take your time. Let's see the graph. Don't forget the plus 30. It is a 4x cube. It's a negative 6x square. See, teaching these things in US curriculum, it becomes easy because there's a graphing calculator. So the pleasure of understanding calculus increases. Whereas if you see in CBSE, we just know how to solve problems. We never understood what is the real life behavior. Let's see how the trend comes. Look at that trend. So those points are what? Those points are, we have a -2 as a point. All right. At -2, if you see, look at the graph at -2, it has gone up peak. So so at -2, it is 0. Then between 2 and 4, at 3, look at 3. At 3 also the function has taken a dip. Right? So the function is something like this. At -2, the function has taken a dip like this. At 3 again, the function has taken a dip like this, and then it's like this. So at 3, the slope is 0. At 2, the slope is 0. Function is decreasing. Function is increasing, decreasing, increasing. That's what she has plotted. And go back to grade 10. This was a cubic function. How many roots you should have? Okati, rendu, more. These are the 3 roots of the function. Calculus is interesting. The only thing is that the way we learn it, we only know how to rectify it and don't get to the trend. Where does this help me? Tomorrow when you study something like, have you seen, this is say an alternating current y equal to sine omega t. Current alternates, so sine omega t, a sine function. I want to design a function, I want to design an apparatus, okay, think, where, I should be able to dim a light and increase the intensity of light with some app-based something, So what do you do in that app? There will be some scroller bar. You'll just push the scroller bar and you see that the light illuminates. And you will be again pulling it down. The intensity will go down. What exactly are you doing? You are increasing the voltage to the bulb. You are reducing the voltage to the bulb. How do you control that mapping? That means these sort of points are called zero crossover points. Every time you have to catch such points, because at this point the voltage becomes 0. Again, the point can be increased. So you have to match these zero crossovers. There's where the use of calculus comes. What we know, in 95, in 2024, this question came, we just rectify that. Whenever trend, if you go by a business trend, look at the share price. It picked up a peak. Some war happened in Iran, the share nosedived. And after that, there's been a lot of foreign investments. Where should you buy the share? That is called your hunger to take risk. Zoe bought here. Yes, then Neha next day bought here. Zoe is now sad. I should have bought here. What we get carried away, we see a growing stock and we say, hey, last year Neha took that share. Oh, she's having so much of money. And like an idiot, just because Neha's money is increasing, you're buying the share here. If you buy the share here, The trend analysis shows that it will take a peak and it will fall. You are idiot. So how much is your hunger to take this? You are thinking that the dip is here and next day it takes a further dip. Then you think, where is my stop loss? Where should I release? Should I hold it? Hold it, because every day your value is reducing, reducing, reducing. Right now the market is like that. The rupee is not doing good. Then foreign exchange are not good. FII, all foreign investors have pulled their money back. War is going on. Every share has come down. Many shares. Should we buy them? And how long is your holding? They will say, buy if you can forget for 2 years. Sometimes I have forgotten for 2 years, but after 2 years, my life is more miserable than what it was. So that's called your ability to. So in share market, we say simple. If you can forget that money, don't think that that money will multiply for you. You just think that you are able to throw that money into dustbin and not cry about it. Sometimes some shares have made loss. Again, some shares are going to go peak. If you buy here also, there's a lot of profit chance. But ultimately, the share market is like this. If you think you have bought a lot of shares here, please be rest assured you will buy many shares here also. And they will all come. Karma cycle is ultimately zero. Okay? Ek aur problem dekhe? Now getting a hang of it. When you do these problems at home, what Ananya is doing for us, try to do that. Then you'll enjoy doing the problem. Chalo. Okay. I have a function f of x is equal to sine 3x. F of x is equal to sine 3x. But however, children, what is a sine function? Sine function can take inputs on R, you know that. But they have said x belongs to 0 pi by 2 in this manner. 0 pi by 2 means both are included. So let me first draw my domain. My domain axis will be, how will this domain axis look like? Beta, tell me. 0 and pi by 2. So, and since this is going to be a trigonometric function, so let's draw it in this manner so that we get a hang of the function. So 0 and pi by 2, that's it. 0 pi by 2. I hope, children, you have understood that whatever jing bang you do, your entire jing bang has to be done within this. You have to analyze your f dash x within this only, with both the endpoints covered. Shall we? Question tells me, find the intervals when the function is increasing, when the function is decreasing. Very good. So I write, let us solve f dash x, which is equal to how much? Cos 3x into 3. So it is 3 cos 3x. Agreed, beta? Now f dash x is equal to 0. That means 3 cos 3x should be equal to 0. Or cos of 3x should be equal to 0. 3x should be equal to, tell me the values. If cos theta equal to 0, theta is equal to odd multiples of 2n plus 1. No, never hesitate, never hesitate. Look here. The cos function starts from here. What is this point? Pi by 2. Pi by 2. Pi by 2. Here it will take cos 0 is 1. And at pi by 2 it's again 0. So all pi by 2's. But look at the pi by 2's. This is the odd pi by 2 minus pi 1 pi by 2. 1 pi by 2. 2 pi by 2 is pi, where it will take a full value. 3 pi by 2. So we will say 3x should be equal to 2n plus 1 pi by 2. Do you agree? And n's value is what? N is equal to 0, 1, 2, 3 and all. Right? But understand, 3x is equal to, you need to do all your studies between 0 and pi by 2. 0 and pi by 2. So What should be the value of x now? Is 3x equal to 2n plus 1 pi by 2? So we can write for x belonging to 0 and pi by 2, at how many points 3x can be equal to 0? Cos of 3x. 3x should be equal to pi by 2. The cos function between here and here, where the cos function can be 0? Only at pi by 2. So I can write 3x is equal to pi by 2. So the value of x is equal to pi by 6. Pi by 6 is a 30 degree. Alright children, I hope you are not getting confused here. Okay, I'll explain that. This is pi by 2, so this is pi by 45, right? This is 45 degree and I'm supposed to be at 30 degree. So this is a critical point. Pi by 6 is a critical point. Alright children, the function is sine 3x. Sine 3x's derivative is cos 3x. Cos 3x will show a 0, means a 0 value here. Usually cos function shows 0 where? Cos function will show 0 here and here. Look. Don't get confused. Okay. What is this point? Negative pi by 2. I am just plotting a cos function and I'll remove it, okay? This is cos function. This is cos x. You are plotting cos 3x. And cos 3x, the function should go through pi by 6. Okay, we found that. So this is a critical point. So what are your zones now? Your zones are, you are examining fx in where? 0 and pi by 6. So you need to check your f dash x. So your f dash x is 3 cos 3x. Now take a value between 0 and pi by 6. 3 cos 0 and pi by 6. So it is up to 0 to 30. Even if you take 30, 30 into 3 is how much? 90. So up till 90 cos is always positive, right? So we can always say f dash x is greater than 0 in 0 pi by how much? 6. We are not using pi by 6. Even if you would have used pi by 6, still the function would have been greater than 0. Is this logic understood now? Let's see the next logic. So if this is greater than 0, so we say fx equal to sine 3x is increasing. That means in this, the function is increasing. Okay? Now let's see the next one. How is fx in pi by 6 and pi by 2? Pi by 6. So let's see what is our f dash x. Our f dash x is 3 cos 3x. Pi by 6 means 30 and pi by 2 means 90. So I'm taking a value which is say 40 degree. X equal to 40 degree. You can just test here. If x is equal to 40 degree, then 3 cos 3x is equal to 3 cos 120, which is negative. So I write f dash x is negative in pi by 6, negative in pi by 6, pi by 2. Therefore fx equal to sine x, sine 3x is decreasing. Clear? Just keep those options open. Whenever these things come, 3x, so we can plot this if 3x is close. Acha, another one thing. What is the minimum value out here? Pi by 6. That is 30. 30, but you cannot, 30 means you can't touch 30 beyond 30. At 30, it becomes 90. Cos 90 means you are still positive. But this is not 30, it is 31. So you fall into the negative zone. Okay? So Let's take it rest on our next class. We'll still do some examples and we'll do all problems. Don't worry. I think we have one more problem and then we have exercises. Just check these things, how these things are plotted out, because your values can be only between here to here. ठीक है?